Welcome to 5.1 Notes. Here's what we're going to try to figure out in 5.1. It's a new chapter. We're going to learn all about radicals, square roots and cube roots and all those kind of things and what to do with them. So our goal is to find out the nth root of a number, evaluate expressions with rational exponents, that's something new, and solve equations using the nth roots, So I'd start off with asking this question. If we know that the square root of a times the square root of a is equal to a, what would that make the question marks in this problem if they multiply up to a to the first? So what to the a to the what power times a to the same power is equal to a to the first? The answer is a to the 1/2. A to the 1/2 times a to the 1/2 is equal to a to the 1, because if you have two numbers with the same base and you multiply them together, you have to add the exponents. So 1/2 plus 1/2 is 1, which means that, and this is the key to the whole chapter so far. I think that, well, so far it's just started, but the chapter is that the square root of a is equivalent to a to the 1/2. And you should probably write that down, because that's like a big deal. That's something brand new, and it's something you can do. And if you wanted to try it out in your calculator, just do 9 to the 1/2 power, or you could do 9 to the 0.5 power instead of 1/2, and you should end up with 3. It'll tell you that. If you take something to the half power, it's the same as taking the square root. So that's the first big deal. And I think it comes back to this notion. If you know what square roots do, then you should be able to know that those both make sense as 1/2. So therefore, by extension, we have this little way of converting between radical form, that's the fraction, or the square root form, and the rational form. So for instance, if the nth root of a to the m is equal to a to the m over n, where the m attached to the a is the numerator and the n, the part of the root, is the denominator. So for instance, I'll get you started, and then I'd like you to try this. This is y to the 2/3 power. You see, the 3 is the root, and the 2 is the power. Try the next few. Pause the video and try the next couple on your own. Okay, so let's see. This would be x to the 5/4. This would be z. Now, there's no power there. So what is it? Well, square root is the default. So this is going to be a to the z to the 7/2. Because in the previous slide, we had the square root of a. Well, the square root of a was equal to a to the 1/2, a to the first power. And the 2 is the index. That's called the index here. And if there's nothing there, it defaults to 2. Sometimes you'll see that on a calculator, and sometimes you won't. So this 2 in the next problem is the square root of a to the 3rd. And by the way, that would be the same as the square root of a to the 3rd, like that. They mean the same thing. You could take the square root first, or you can take the 3rd power first, whichever is easier. Next one, this is the 10th root of b to the 9th, or the 10th root of b, and then take the whole thing to the 9th. To the other one. But that's not so important at the moment. So anyway, make sure you have those down, because those are your kind of key to being able to convert between radical and rational forms of these problems. So the other thing we need to be able to do is make sure you know how to do this in a calculator. So use the definition of rational exponents to use a calculator to determine the answers for these things. So if you're using a Google calculator, if you're using a TI calculator, hand calculator, whatever it is, make sure you know how to do these kind of problems. So the example here is that if I want to find the 3rd root of 4 to the 2nd power, this thing in here, the first thing I'd do is I'd convert it to 4 to the 2/3 power, and then I can pop that into my calculator like this. 4 to the 2/3, and notice that they have 2/3 in parentheses. If you did 4 to the 2/3, that would be the same as doing 4 to the 2nd power divided by 3. And you'll not get the same answer, you'll get 5 something, right? So you want to be able to do these without that mess. So take a moment and figure out these, and then we'll check them. So let's see. I rounded these to 2 places, so let's see what they ended up being. Hopefully you've got something close, 11.18. This one was the same as 4 to the 2/4. Well, think about that. That's same as 4 to the 1/2. That's the square root of 4. The answer is just 2. This one here is 4.33. This one is 4.30 something. This one is 2.54. If you didn't get those, go back and try them again on a calculator or computer, see what happens. If you saw what I was doing it on Desmos. And what I decided to do, if you were paying attention during the time I was getting back to the slide here, was I decided that I would just make a general statement in Desmos, B to the C over D, and then I just kept on changing B, C, and D, and it gave me my answer there. Seemed like an easy way of doing it, but you can do it however you want. Be nice if you made sure you know how to use your calculator, because calculators are important to be able to use, and in this form. So converting to radical form, once again, this is what we were doing in the table, but make sure that you know how to do these. If you need practice with this, pause the video and do that. Otherwise, you can skip this part. So this one is the square root of 10 to the third, or the square root of 10 whole thing to the third, however you want to write it. This one's this, oh, wait a second, this one's the square root of 16, right? I think I can simplify this one a little bit. See, now it would be helpful to do this as the square root of 16 first, and then take the third power, because the square root of 16 is 4, whereas the 16 to the third power is something huge, so I don't really care about that. I'd rather do the square root of 16 is 4, 4 to the third power is 64. Sometimes it works out nice like that. This one's the fifth root of 20 to the sixth. And this would be, make sure that you don't write, if you're doing these by hand, make sure you don't write them so that you need to be able to tell that that 5 is an index and not a number in front. So there's a difference between 3 square root of 2 versus the cube root of 2. It means different things because this, how big the 3 is. If you make the a 3 that's too big, you might not be able to tell the difference. All right, so here's another core concept about roots and taking their roots, taking the nth root of something. If the index, that's what they're talking about, the nth part, we're always talking about it like this, the nth root of a. If the index is, or what are they saying? The nth root of, so if a is less than 0, so if n is even, so like a square root, for instance, if you take the square root of a number that's less than 0, you don't have any real roots. You have imaginary numbers, right? So if a is less than 0, you don't have any real answers. If a is equal to 0, like the square root of 0, it's 0. The square root of the fourth root of 0 is 0. The 10th root of 0 is 0. That's true for odd numbers as well. And if a is greater than 0, it says here that there are 2 real nth roots. And now, usually we don't care about the negative one, but sometimes there's times when that makes a difference. So I wouldn't be picky about it, but I don't know what's going to happen. So I would say that the important thing here is that if you take the nth root of a negative number and the n is even, it's not going to give you an answer that's a real number. Whereas if you have an odd number for n, like a third root or a fifth root or something like that, you're always going to have one answer. You're going to have one answer, or it's going to be 0, which is one answer as well. So when it says find the indicated nth root of a, it would be something like, what's the third root of negative 216? Well, that falls into this category over here. And even though it's negative, there's going to be there's going to be an answer. In fact, the answer is negative 6, because negative 6 times negative 6 is 36. But 36 times negative 6 is negative 216. Negative 6 to the third power is negative 216. So there you go. In this, whereas in this one, we have an even index, and what to the fourth power is equal to 81. You could break down 81 and say, oh, that's 9 times 9, and those are a bunch of 3s. Yeah, that would be 3 to the fourth power, right? So the fourth root of 81 is 3. But according to this statement right here, we technically should be saying it's plus and minus 3. So you'll see that's because negative 3 to the fourth power is the same as positive 3 to the fourth power. They're both positive 81. So that's, we don't usually think about that with square roots, because square roots are defined by the positive part of the thing. All right, so you can do some practice if you need it. Try some practice here. Pause the video. If you want to skip this, then skip it. So let's see, the fourth root of 16 is plus and minus 2. The square root of negative 49 is no real numbers because it would be plus and minus 7i, right? Or it's just 7i. The third root of negative 125 is negative 5. And the fifth root of 243 is 3. 3 to the fifth power is 283. 243, sorry. I hope you checked out right. The next part is going to be how you solve using these kind of things. This is brand new, but it's not really new. The first thing to do would be to isolate your perfect whatever it is. So in this case, I'm going to divide both sides by 4. X to the fifth power is equal to the fourth, would be the 128 divided by 4, 32. Now, think about this. When we had this x squared, one way of solving those was to take the square root. Square roots undo squares. Well, fifth roots undo fifth powers. So the fifth root of both sides would give us the fifth root of x to the fifth. In other words, x to the 5/5, right? That's just x to the first. That's what we want. And the fifth root of 32 is 2, since 2 to the fifth power is equal to 32. So there we go. On this one over here, the perfect part is already isolated. So all we're going to do is we're going to take the fourth root of both sides. So we'll have, in this case, I would do it like this instead of the way the book is suggesting it, but I don't know. I do it like that because that's what we did before for square roots. And then say, okay, then x minus 2, or x minus 3, is equal to plus and minus the fourth root of 21 for the same reason that that worked for square roots. So our answer is 3 plus and minus the fourth root of 21. And that's the final answer, those two answers. So that's solving these things. And we've done solving, we've done changing between forms, and that's probably enough for this video.